One way the army trains its soldiers is by using war games. During war games, soldiers shoot each other just like a real war, but no one gets killed. This is one example of simulation. When an airline wants to train its pilots to fly a commercial aircraft, the airlines use simulators. When a trainee pilot enters a simulator, it feels just like a real aircraft. However, it is all computer generated. This is another example of simulation. So what is simulation? To simulate is to try to duplicate the features, appearance and characteristics of the real system.
Simulation is popular in business and governments. City councils simulate traffic flows to solve traffic problems. Universities conduct investment games to teach students about investment. Firefighters simulate fires to learn about how to rescue people. Simulation has several advantages. Firstly, we can carry out simulation easily using computers. Usually we use spreadsheet programs like Microsoft Excel. Secondly, simulation can solve large and complex problems. For example, if a city council wants to make a model of the city, it is very complicated. It is impossible. It is easier to carry out a simulation of the city than making a model of the city. Thirdly, simulation allows what-if questions. So, for example, if a traffic engineer wants to investigate about the traffic, so he can investigate what if the road is made into one way. And finally, simulation does not interfere with the real world. So back to the example of a traffic engineer. So he can do many things using simulation. He can make the road one way, put a traffic light, but he can do it during the simulation, not using the actual road. However, simulation has one disadvantage. Simulation does not generate optimal solution. So for optimal solution, the cost is minimized. But we don't know whether the cost is minimized or not. We know that if we carry out simulation, this is the answer for a certain set of conditions. One method of carrying out simulation is called the Monte Carlo method. Now in Monte Carlo, there are many casinos where people gamble. In gambling, people take chance or use probabilities. So that's why this method is called the Monte Carlo method, because this method uses chance or probabilities. The Monte Carlo method, I will use an example about Harry's Auto Tires. In this shop, the owner wants to carry out a simulation for the demand of tires. He looked at all his records and he got this data. He found there are 10 days where the demand is 0, 20 days where the demand is 1, 40 days when the demand is 2, and so on. Altogether there are 200 days. We add a column which is called probability. This represents the probability that if I select a day, demand is 0, 1 and so on. So for demand is 0, there are 10 days, the probability is 10 over 200, which is 0.05. Demand is 1 day, the probability is 20 over 200, which is 0.10. Then 40 over 200, 0.20, and so on. And one way to check the answer is the total must be 1. We add another column, cumulative probability. Okay. Here we add the probability 0.05 plus 0.1, 0.15 plus 0.20, 0.35, 65, 0.85, and finally 1.00. So to check your answer, the final value must be 1. Okay. Then we add another column, which is the random number interval. So this interval shows the property that if I select the number, the property is 0.05. The next interval is 0.10 and so on. We use 100 numbers. All the way until 100. So to be consistent, I want all numbers to be two digits, like 11, 12. So let's say 1 to make it 2 digit, I write as 01, then 02. Okay. 100 is a 3-digit number. So to make it 2 digit, I remove the 1, so it becomes 0, 0. Now the first property is 0.05, which is 5 over 100. So I have 100 numbers. Now I want to choose 5 numbers. So I start from 01 until 05. So the first interval is 01 until 05. The next property is 0.10, which is 10 over 100. So now I use 10 numbers starting from 06. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 06 until 15. Then continue. But to help us, we can use the cumulative property. So for example, 01 until 05. So this is 05. After 05 is 06 until 15. Then 16 until 35. 36 until 65. 86 until 0, 0.
This is part of a random number table. To get the random numbers, start somewhere and move in a particular direction. It is not necessary to start at the first number of the table. You can start anywhere in the table. In other words, start at random. One way to start at random is to let a pencil fall on the table. Suppose the pencil falls on the number 60. If you choose to go to the right, the other numbers selected are 95, 89, 50, 33, 50 and so on. You can also move in another direction. Suppose you want to go down. Then beginning from 60, the other numbers selected are 44, 57, 82, 10, 24 and so on.
In this table, the important columns are the first and the last column. Well, because my whiteboard has limited space, I'll remove the columns which I don't need. So we want to carry out the simulation for the next few days. So we add a column which is day. We can do the solution for any number of days. 10, 15 is up to us. So let's say I choose 10 days. The next column is the random number. Short form is Rn. So this random number, we get it from the random number table, which I'll discuss after this. And the next column is the simulated demand. These are the random numbers from the random number table. For day 1, random number is 60. 60 is between 36 to 65. So the simulated demand is 3. 95 is between 86 to 00. So the simulated demand is 5. 89 is between 86 to 00. So simulated demand is 5. Now we continue. 50 is between 36 to 65, 3, 33 between these two, 50, 3, 95, 5, 13, this one, 44, 3, 34, 2. Okay. Let's say I want to find the average demand per day. So I find the total demand, which is 8 plus 5, 13, 16, 18, 21, 26, 27, 30, 32. So for this simulation, the average demand equals to the total, which is 32, divided by 10 days, because the simulation is for 10 days. So which is equals to 3.2. We carry out a simulation using a different set of random numbers. Okay. So the total is 7, 12, 15, 14, 20, 30. So for simulation 2, the average demand equals to 30 divided by 10 is 3.0. We find that for different simulation, we get different values for the average demand. Well, even though the values are different, they are about the same, 3.2, 3.0. So that means on the average, the demand is around 3 tires per day.